Welcome back to AI Edge Daily, where we break down the latest breakthroughs in artificial intelligence. I'm your host, and today we're diving into something that could fundamentally change how we interact with large language models. Google researchers have just introduced a groundbreaking concept called faithful uncertainty, and it's poised to transform one of the biggest problems plaguing AI systems today: hallucinations. If you've spent any time working with large language models, you know the frustration. You ask ChatGPT or Claude a question, and sometimes you get a perfectly accurate answer. Other times, you get something that sounds absolutely authoritative and completely fabricated. The model confidently presents false information as if it's gospel truth. These hallucinations have been a persistent thorn in the side of AI adoption, especially in critical fields like healthcare, law, and finance, where accuracy isn't just important, it's essential. But here's where Google's new research gets interesting. Instead of trying to make models always give you a definitive answer, what if we let them admit uncertainty? What if, when a model isn't sure, it could tell you it's making an educated guess rather than stating it as absolute fact? That's essentially what faithful uncertainty enables. Let's break down what this actually means. Faithful uncertainty is a technique that allows large language models to provide responses that explicitly acknowledge their level of confidence. When a model encounters a question or topic where it doesn't have strong training data or where the answer is genuinely uncertain, it can now express that uncertainty faithfully. Instead of hallucinating details to fill in the gaps, the model can say something like, "Based on my training data, here's my best guess, but I want to be clear that I'm uncertain about this particular aspect." The researchers at Google conducted extensive testing and found that this approach significantly reduces hallucinations while maintaining the utility of the model. Think about that for a moment. We're not sacrificing functionality to gain honesty. We're gaining both reliability and transparency at the same time. How does faithful uncertainty actually work under the hood? The team developed methods to calibrate the model's confidence scores. Essentially, they trained the models to better understand when their outputs are reliable and when they're not. They also created mechanisms that allow the model to express this uncertainty in natural language that humans can understand and act upon. One of the clever aspects of this research is that it doesn't require completely retraining massive models from scratch. The techniques can be applied to existing large language models, which means we could potentially see this integrated into systems we're already using within months, not years. The implications here are enormous. In the legal field, imagine a legal research assistant that can tell you, "This case precedent seems relevant, but I'm not completely confident in all the details, so you should verify this independently." In healthcare, imagine a diagnostic support system that says, "These symptoms could indicate this condition, but I want to be clear this is my best inference and not a confirmed diagnosis." These kinds of honest uncertainties are actually far more useful than confident hallucinations. But there's another dimension to this that's worth exploring. Faithful uncertainty also sets up a framework for better human-AI collaboration. When users know that an AI system is being honest about its limitations, they can calibrate their trust appropriately. They can use the AI as a thinking partner while maintaining healthy skepticism, rather than either blindly trusting everything it says or dismissing it entirely. Google's research also revealed something interesting about user behavior. When models expressed uncertainty appropriately, users actually rated their responses as more helpful, even when those responses were less definitive. This suggests that people value honesty and transparency in AI systems more than false confidence. The testing conducted by the researchers included challenging scenarios where hallucinations are particularly common. They tested on factual questions, reasoning tasks, and creative problems. Across the board, faithful uncertainty reduced the number of completely fabricated claims while maintaining response quality for questions where the model had strong training signal. Now, let's talk about what comes next. The researchers have shared their methodology with the broader AI community, and we're already seeing other organizations exploring similar approaches. OpenAI, Anthropic, and other major AI labs are investing heavily in uncertainty quantification and calibration techniques. This is becoming a priority across the industry. What's particularly exciting is that this research opens up new possibilities for fine-tune.